The Artemis plan works only if the Moon can teach NASA something the Moon itself cannot fully test: how to survive when Earth can no longer rescue the mission. That is the Mars problem inside Artemis. The Moon is dangerous. It is airless, dusty, cold, exposed, and unforgiving. But the Moon is still close enough for Earth to matter. Mars is not. On the Moon, failure can still become a race. Race to stabilize the crew. Race to return to orbit. Race to bring people home. Around Mars, failure can become something worse. Waiting. Waiting for a message. Waiting for a launch window. Waiting for a system to recover. Waiting inside a vehicle or habitat that has to keep functioning because there is nowhere else to go. NASA's Moon to Mars plan is not one jump. It is a sequence, because the hard part is not just building a rocket. The hard part is proving the chain. Launch, transit, docking, landing, power, life support, radiation protection, surface work, medical autonomy, ascent, return. Every link has a lunar version. Mars has the harder version. That is why a successful Artemis program can still leave one question unanswered. Does the system only work near Earth, or can it still work when Earth becomes advice instead of rescue? NASA has a clear reason to go back to the Moon before Mars. The Moon is close enough to practice deep space operations without committing a crew to an interplanetary mission. It gives NASA a real surface, real dust, real lighting, real terrain, real gravity, even if it is weak, real darkness, real thermal extremes, real operations far outside low Earth orbit. That matters. A simulator cannot fully test what happens when a crew has to live inside hardware that is sitting on another world. A lab cannot fully reproduce the pressure of a landing system, surface suit, rover, habitat, and mission clock, all depending on each other. So Artemis is not a side quest before Mars. It is the proving ground. NASA's own architecture describes a path that grows in complexity: human lunar return, foundational exploration, sustained lunar evolution, and then humans to Mars. That sequence is the clue. The Moon comes first because Mars is too expensive, too far, and too unforgiving to treat as the first full test. But there is a trap hidden in that logic. The Moon can prove that a piece of the Mars chain works. It cannot prove that the whole chain will keep working for the length of a Mars mission. The Moon can test a habitat. Mars tests whether that habitat stays livable when every repair, every filter, every sensor, every spare part, and every crew decision has to survive months or years of dependency. The Moon can test suits. Mars tests whether surface work remains possible after the crew has already spent months in transit. The Moon can test power systems. Mars tests whether power, dust, maintenance, and return timing all behave together. The Moon is the right test. It is just not the final exam. NASA's Human Research Program breaks deep space risk into 5 major hazards: space radiation, isolation and confinement, distance from Earth, gravity fields, hostile and closed environments. The important part is not just that these hazards exist. The important part is that they stack. Radiation affects health. Isolation affects performance and decision-making. Distance affects communication, medical care, and resupply. Gravity changes the body. A closed environment turns air, water, microbes, noise, lighting, sleep, and waste into engineering problems that never turn off. On a short mission, a problem can be managed. On a long mission, the same problem gets more chances to become the main event. That is the difference between a dramatic failure and a slow systems failure. A clogged filter is not cinematic. A tired crew is not cinematic. A delayed medical decision is not cinematic. A water processor drifting out of tolerance is not cinematic. But Mars does not care what looks dramatic. It cares what keeps working. That is why the Mars problem is not one villain. It is accumulation. Small failures become schedule pressure. Schedule pressure becomes crew stress. Crew stress affects maintenance. Maintenance affects life support. Life support affects health. Health affects decisions. And decisions affect whether the mission still has enough margin to come home. Distance is the simplest Mars problem to understand and the hardest to live with. On the Moon, Earth is still a presence. It is visible in the sky. It is only days away. It can send instructions, analysis, and emergency planning on a human timescale. That does not make the Moon easy. It makes the Moon survivable in a different way. Mars changes the relationship. At Mars distance, mission control can still help, but it cannot always intervene. A doctor on Earth cannot step into the habitat. A replacement part cannot arrive tomorrow. A rescue vehicle cannot leave on demand. Even communication becomes a different kind of tool. Instead of real-time conversation, the crew may be dealing with delayed messages, pre-planned procedures, and decisions made with the people and equipment already on site. That is where autonomy stops being a futuristic feature and becomes survival infrastructure. The spacecraft has to diagnose more. The habitat has to tolerate more. The crew has to decide more. The mission has to absorb more. This is the part Artemis has to teach carefully. Not just how to land, not just how to plant hardware, not just how to operate on the Moon. How to build a mission that can keep going when Earth is no longer close enough to be the backup plan. For Mars, the question is not whether NASA can do hard things. NASA has already done hard things. The question is whether the Moon program proves the right hard things. It has to prove repeatability. One impressive mission is not the same as an architecture. It has to prove maintenance. A habitat that works on day one is not the same as a habitat that can be trusted after dust, vibration, thermal cycles, crew error, and component wear. It has to prove medical autonomy. Mars crews cannot depend on Earth the way station crews or lunar crews can. It has to prove life support closure. Air and water systems are not background equipment on Mars. They are part of the crew. It has to prove surface logistics. Power, mobility, communications, and shelter cannot be treated as separate boxes. On another world, they become one survival web. And it has to prove that humans can still make good decisions inside that web. Because the most advanced spacecraft is still carrying a small group of tired people through a long chain of consequences. That is the real threshold. The Moon can show NASA which systems look ready. Mars will reveal which systems actually are. So the problem with Artemis is not that Artemis is wrong. The problem is that Artemis can look successful before the Mars problem is actually solved. A beautiful moon landing can hide a deeper question. Can the same architecture scale into years? A working lunar habitat can hide a deeper question. Can the same life support logic survive when resupply becomes rare and rescue becomes unrealistic? A successful surface operation can hide a deeper question. Can the crew keep operating after deep space transit? Radiation exposure, sleep disruption, isolation, and delay have already started to take a toll. This is why the Moon matters so much. It is not just a destination. It is the last place close enough to expose failure before failure becomes interplanetary. If Artemis proves the right systems, Mars becomes less like a gamble and more like a mission. If Artemis proves the wrong things, the Moon becomes a spectacular demonstration that still leaves the hardest part untouched. That is the Mars problem inside NASA's Artemis plan. Not whether the Moon is worth returning to, it is. The question is whether the Moon can reveal enough of the truth before the first Mars crew has to live with the answer.